Alright guys, so Um, welcome back. And in the last video, we were pretty much setting up our collisions and our triggers for obstacles and for our pickups. So things are coming along just well, and yeah, it seems that everything is working fine. Of course, as you can see, the camera is not cooperating with us at the moment, so we're gonna try and fix that real quickly. Now, before I show you the kind of the better solution, I'm just gonna try a quick fix here. I'm gonna just drag and drop the camera object as a child of my taxi, and if I hit play now, I think things should be a little bit better. So when I increase the speed up by 1, as you can see, our camera is going with the taxi. And if I now go right and left, as you can see that it doesn't look pretty, but it is working. And also when I jump, the camera is jumping with me. So you can probably already tell what the problem with just simply parenting the camera is. Obviously, this motion, I don't want this. And also, I really don't want the camera to be jumping. So what I'm trying to say is I want the camera to be following the taxi, but I don't want it to really move in the X and the Y axis. That is, I don't want the camera to be moving sideways, and I also don't want the camera to be moving upwards. But I do want it to be moving in the Z direction. So yeah, parenting the camera to a game object is usually always like just a little prototype step that you might do, but it's never really going to be a solution to this problem. And another reason why it's not a great solution is what's about to happen right now. So just watch as the taxi falls over. It's just gonna go crazy. And there we go. All right. So for this reason, almost in no game of yours you're gonna have this, because if your player is gonna be jumping around or something like that, the camera is just gonna spasm out like that. So it's almost never a good idea. So I'm gonna go ahead and remove the camera out to back outside, and we're going to work on making a camera script. Now I've gone ahead and made one, so you're going to do the same. You're going to go here, right click, create a new C# script, and we've called it the camera script. Okay, so now I'm going to walk you through what the camera script does, and we'll see how it works. Okay, so here's what we want to do. Now that just like the car movement script took care of the taxi, right? We want the camera script to be taking care of our camera game object, okay? Like we previously talked about, we can use scripts to basically affect how game objects move and such, interact basically, okay? All right, so let's talk about English first, okay? Let's talk about what we want to do in English, because computer science is more often than not just pure logic and just talking to yourself. It's unbelievable, really. What I've realized in my life, whenever I would get a computer science problem, or if I had an assignment or something, in the very beginning, or whenever I'm creating a game, or if I'm stuck on a problem, I made this mistake of always like just opening up a script and then starting to suddenly write some code. But over time, I realized that's never the solution, and just kind of thinking about it really helps. So before I show you the code, let's just talk about what we need to do. All we want is we want the camera to move a certain distance behind our car. Okay. Now, in between the videos, by the way, all I did was I just changed the positioning, so it's a little bit more symmetric. I moved my taxi to 0, 1, 0. Okay. So I just wanted to have the taxi at the very middle of my screen. Okay. So I did that. And what I did was, just to have a good view, I also moved my camera, as you can see. I've also moved it its x-axis onto 0. Okay, so as you can see, it's right behind. It's when I put it to 0, it's right behind my game. Now, one way you could do this is basically you could just set the camera, for example, to 0, 0, 0. You could just set it to inside the car. So as you can see right now, the camera, if I run the game, the camera is actually you know, somewhere probably in the floor or something, but it's at 0, 0, 0. And if I set it to 1, then it's inside the car, because that's exactly the situation of the car. Now, if you want to find out a good place for your camera, you can start tweaking these values now. So if I move it to y equals something, and then if I move it a little bit backwards, and, you know, if I rotate it a little bit, you might be able to find a sweet spot, and you might say, hey, okay, look, I like the way this looks. So I was just playing around with it, and I found that -5, 5 in the x-axis, sorry, 5 in the y-axis, z in the, what am I saying? So 5 in the y-axis, -5 in the z-axis, and a rotation of 20, at least for now, looked okay for me. If you feel like you want to go with a different angle, a side-on angle, or whatever angle, go for it, okay? So that's kind of how I came up with those numbers, if you're wondering. So those are some of the changes that I made. I'm going to just go ahead and revert those changes. So -5 for the z, and 20 over here. And I think this camera angle looks fine, at least for now, and we can change it later on. Of course, we haven't done anything yet, so obviously it doesn't follow. But okay, so just to get you up to speed with why things might look a little bit different, all I did was I was just setting up the camera right behind my car, a little distance up, a little bit behind, and at the same x-axis value point, okay? And now I need to think about how to keep the camera the same distance away, up and away, as the car moves forward. Okay, so now that we've thought about it, let's look at the code and see how this is going to happen. Okay, now first of all, in the camera script, what we need is we need the player. Okay, we need the player target because we need to know where the player is, so that depending on the transform position, and again, I wanna emphasize the fact that we want the taxi's transform, okay? So the taxi is going to be moving forward in the z-axis, okay? And if we're going to follow, if the camera is going to follow the taxi, it needs to know at what position the taxi is at any given time, okay? So that's why we need the transform of the taxi, okay? So we need the transform of the taxi, which is going to be our player target. That's where, you know, that's the point that the camera is going to be targeting, okay? The start offset. Now, the start offset is going to be the difference. Okay, so let's go one by one. We've got the player target, and in the start function, I'm getting the player, okay? Now, the way I'm doing this is, the way that I'm initializing this player target is by something, this is a slightly different way than I was doing it before. I'm doing GameObject.find GameObject with tag called player.transform. Okay, so what the hell did I just do? Okay. First of all, let's go on our taxi, and you see that there's a drop-down menu called tags, okay? Now, there are some predefined tags here which we can use, or we can add one of our own. Now, in this case, I'm just going to tag our taxi as our player, okay? Fair enough. Now, whenever we tag objects, we can basically look for them in code by those tags, okay? So earlier on, when I was talking about obstacles, I briefly mentioned tags, but then I was like, oh, hold on, I don't want to talk about it right now. So this is exactly the point where I want to talk about it. So whenever I put a tag on an object, the reason why I do that is because I can look for this taxi now in code by using this player tag, okay? So going back to our code, in order to get the player target, it's a transform, by the way. It's not a game object. It's the transform component of the player target. So what I do is I do GameObject.find GameObject with tag. Okay, so this line of code, what I'm telling Unity, I'm telling, look, I'm looking for a game object with the tag player, okay? So Unity will come here in the hierarchy, and it's going to keep on looking. It's going to look at the main camera. It's going to see, okay, tag main camera, direction light untagged, cube untagged, taxi, boom. That's when it knows that this game object called taxi has a tag player, and that's what it needs. So this line of code right here returns a game object with the tag player. Now, the additional dot transform, I could have done it in 2 lines, but just to get the transform directly, I could have saved this here as a player object and then got the transform, but just to do it quickly, you know, not waste some space, all I have to do is, once I have the game object, dot transform is going to directly give me access to this transform right here, okay? I hope this makes sense. because over here, I'm looking for the transform. I don't really need the player game object. I just need its location, okay? I don't care anything else about the player object. So, I don't need the whole information about him. All I need is the transform, so that's all I'm going to get from him. So I have a private variable, player target. It's of type transform, so it's a transform. And over here, all I'm doing is I'm looking for a game object with the tag player, and by dot transforming, I'm only getting the transform component, okay? I could have gotten the rigid body, the box collider, the car movement script, but no, I don't want any of those. All I want is the transform, so that's what I get here. Now, before I continue, I do want to talk about this. What do I want to say? Well, here's what I want to say. We've talked about public and private, okay? Now this right here is the right way of getting references, okay? The wrong way, or the easier way, could have been, I could have easily said, made this public. Let's remove this from here. And if I save it now, and if I go back, at the moment, I have my camera script attached. Okay, no, I don't. So let's attach a camera script. Okay. Notice, as soon as I make this transform player target public, it gets exposed in the inspector, okay? And now it's looking. Now it's waiting for me to drag and drop. And this is easy because now if I drag and drop my taxi right here, then automatically it takes the taxi transform. And this looks easy, right? And this is the beginner way of doing it. And this is something that you very well may do it, okay? There's nothing wrong with doing it, so to speak, in terms of being a beginner. But this is really considered dangerous. Whenever you make variables public unnecessarily, there's always a risk that you might accidentally access them, and you might change them around a little bit. And it's just considered bad practice in general to make variables public unnecessarily. Now, as I said throughout this particular tutorial, we're not really too worried about that. But I mean, this is just a way. I'm going to be using public variables all the time. If I haven't used them already, I'm sure I have. It just so happens that I haven't, except for speed. But as we go through, I will be using public variables. So it's not like a do or die type situation, but it's just good if you can, in general, avoid using public variables. Now, sometimes it's impossible not to, but usually there is a way around it. But I'm not going to think about it so much. But this is one of those situations where I'm telling you right now that, okay, you can do this, but this is not the best way of doing that. In essence, for the sake of this, I'm going to go back and I'm going to revert back to a private transform player target, because now we know another way of finding game objects, right? So instead of doing public all the time, public blah, you can always look for game objects with tags as well, okay? So that's how I'm doing it over here, and I just did this so as to introduce a new way of getting access to your game objects. So far we discussed where we got this from. The start offset. Okay, look, a little bit of vector maths. This taxi is at position 0, 1, 0, okay? I'm talking about frickin' 8th grade geometry, okay? Three-dimensional, coordinate system, and you've got 0, 1, 0, you've got a dot on 0, 1, 0, and you have got a dot on 0, 5, minus 5, okay? That's what I'm talking about. Two dots, and you're just subtracting vectors, okay? So the start offset here is just basically the difference in the position of both of these game objects, okay? What I'm looking for is I'm just trying to find the difference. You remember back in grade school where you have a, I'm trying to remember, what do you call it? You have a vector and then the head to tail rule where you go from the head of one to the tail of one. That's kind of what I'm talking about here, okay? So think about unit vectors and directions. That's exactly what I'm talking about here. So all we're doing is we're getting their positions and we're subtracting them, because that is the difference between them, right? So what is the offset between this car and this camera? Well, we're just going to subtract them. Now, you might say, well, why do we need the offset? Well, you probably already know, right? Because what we need to do is we need to make sure that the offset in some way or form, at least in terms of like, let's see, the Z of this and the Z of the taxi, you want them to go together, right? You want, as the taxi moves forward, you also want the Z of the camera to move forward, right? That's what you want. You don't want the X of the taxi to move and the camera to move together. You don't want the camera to jump while the car is jumping, but you definitely want to maintain the initial distance, right? That's why we went to the trouble of finding the sweet spot. We found the sweet spot with the camera because we like this view, and this is the view that we want to maintain, right? So that's what we're trying to do here. Let me just make sure I'm at the right positions. Yes. So now we have the offset. This is basically just the difference in their vectors, okay? So I know that, all right, this is the difference. Now, in the update function, what I'm doing is, here's where I'm going to be calculating where and how to update the position of my camera. So as you can see, I have a vector 3 called goal, okay? And later on, I'm just saying transform.position. Now, transform.position here refers to, of course, the transform.position of the camera, right? This camera script is on our camera. So whenever we do transform.position, then it's talking about the transform.position of the camera, right? So all I'm saying is I'm saying that I want the transform.position of the camera to be equal to the goal, and then I'm updating the goal over here. So what am I doing? Every frame, I'm looking at the position of the player, okay, because we have it now. So as the player is moving forward, I'm getting the position, and all I'm doing is I'm just adding the same offset every single time to that position. Now think about that. That makes sense, doesn't it? That makes sense. At the very beginning, we found out the distance or the difference or the offset in between these two, okay? We found out exactly what the distance or the difference was in between them. And now, as the car is moving forward, in every single frame, we find the position of the car and we add the same distance or the same difference or the same offset in between them at the very beginning of the game, okay? We add those two and we call it goal, okay? And this new vector 3, we tell our camera that, look, this is where you want to be, and that makes sense. So as the car moves forward, the camera moves forward. I hope this makes sense. Now I'm going to save this, and some of you might already know what is wrong with this, but I'm going to show you, okay? Now, let's run it. Okay, so let's speed up our taxi. Let's give it a speed of 1, and now we are moving, however so slowly, but we're moving. The camera is moving also. That's pretty cool. Look at that. The camera following right here. Camera following my car. Works well. Now, as soon as I move right, hold on, wait a second, we got a problem, right? So the camera is moving right along with the car. Let me try jumping. Hey, look at that. The camera is jumping with my car. That's not what I want. That's certainly not what I want. So let's think about this. Now, what went wrong here? Did we code wrong? Well, certainly not, right? We talked about it. We talked it through. We said, hey, this is the difference. Every single frame, we find the position, and we're adding it. So we're pretty much, I mean, it's doing what we told it to do. I mean, computer programs by default are dumb. Computers are dumb. So that means that clearly we're doing something wrong because this program is doing exactly what we're telling it to do. So let's think about this. Okay, what do we want? We want the Z axis, the Z coordinate of the camera to be changing. Okay, we want this to remain the same distance away as it is from the beginning. Okay, that's fine. But we don't want these two, the Y, for example, or the X, for example, to be moving. So we want the X and the Y to pretty much stay put, okay? And in its current state, it's not doing that. So why don't we just force them to be the same? So this is going to be our goal, right? This is going to be our goal. So why don't we tell this vector 3 before we actually make it, let me just remove this for a second. Okay, let me just remove this. Okay, before I update my camera position as goal, why don't I do something like this? Goal.x equals 0. Okay, so what I'm saying is, okay, we've got the new position that I want to set the camera as, but the problem with this position is that if I'm moving right and left, it's also moving right, and it's also going to move the camera right and left. But what if I put the position, the X position, as 0? Because look, the camera's X position here is right in the middle, right? The taxi is going to be at 0, and at the game start point, the camera is also at x equals 0, and we don't want the camera to be moving right and left with the car, right? So why don't we just make the position of the camera 0 by default every single time? So if I do goal.x equals 0f, and then I pass it in, then whatever this goal is here, whatever this goal is, this goal has some x coordinate, some y coordinate, and some z coordinate. But what this line is going to do is it's going to take that x coordinate, okay, and it's going to make it 0. So this is going to make it 0, comma, some y coordinate, comma, some z coordinate, okay? Now, this sounds good. This sounds good, right? Because when goal goes over here, and when I equate it transform.position, my camera is always going to stay at its starting position. Okay, we also want to do the same thing for the y, okay? Now, if we don't change it, if we leave it in its current state, what's going to happen is every time I jump, then my y will also go up and down, okay? And that's not what I want, because if I'm moving up, if my camera is moving up by exactly the same amount as my car is going up, then it's going to be really goddamn hard to see my car actually jumping. Because think about it, if your camera is moving up by the same distance as your car is moving up, then it's not gonna look like you're jumping, really. It's just gonna look weird, okay? So we want to stop the camera from moving from this Y position as well. So in essence, what we want is we don't want the camera to be moving in this direction, that is in the X direction. Oops. We also don't want the camera to be moving up or down. All we want is the camera to just follow, okay? So how are we going to do that? Well, you've probably guessed it by now. We can change the goal.y equals 5f. And what this does, if you're wondering where the 5 came from, well, let me show you. The default position, the Y position of the camera is at 5, and we want it to stay that way, okay? As it's going forward, we don't want the Y position to move. We only want the Z position to move, okay? So here's what's happening. Goal.x changes the goal. So over here we had some x, some y, and some z, and now we have 0 when we do goal.x equals to 0. So it's saying that the x position of our camera is always going to be 0, and now what we're doing is we're saying, hey, look, the x position is still going to be 0, the y position is always going to be 5, and the z position, well, the z position is free to change. Now, this is going to change depending on where my car is, that is, my player target transform is, okay? So this kind of looks kind of nice. So let's save this. Let's try and run our game and see what happens. Okay, so let's give our taxi some speed. And now we are moving. Okay, it seems to be moving. Now I'm going to try and move right. And look at that. Look at that. The camera isn't moving. The camera is staying still. Now, of course, he's going outside our screen. That's our problem. That's our camera's positioning wrong. But look, it's not moving. It's not following. And similarly, when I jump, hey, now look, it looks like it's jumping. You can see the shadows on the floor and everything. So this is beautiful. Also, when it falls off now, it's not going to do all that craziness. I mean, that it was doing. Of course, it's not supposed to fall off, so it's still going to be crazy because the camera is still going to be following the car, but maybe not as crazy as it was before. But ideally, your car shouldn't be falling off the edge. I mean, you know. So you see, that's not as crazy as it was before. Okay. So I think that is all for this tutorial. Now, I know that I spent an insanely long amount of time talking about such a simple thing. So I want to apologize to those of you who might be a little bit more advanced and who've just been like really pulling their hair out. I do encourage all of you guys in general to listen to these tutorials at a slightly faster pace, like 1.25x or 1.5x. That's how I always listen to them. Even if you have to listen to it a couple of times, that's okay, but just listen to it at slightly faster, and I just feel like that'll be much more beneficial, and especially if you're someone who's just kind of brushing over or just kind of getting a Unity review type situation, then you can quickly go over it as well. But yeah, the reason why I'm going so slow is I just can't help myself, really, because I know that there's going to be people who are, you know, who are going to have questions. So I want to make sure that I want to err on the side of caution, per se. and I want to go through all the details and make sure that everyone is following. Because look, this code that I'm writing, I mean, if you're following along or if you're writing along, that's fine. But just by copying it, you're probably not gonna get it right. So I need to make sure that you can I can explain it to you in such a way that you can basically make this code your own. You can basically own this code, so to speak. There's no point if you look at my code and if you copy along and you've got the same thing kind of going in your laptop, but you don't really know what's going on. So that's what I'm trying to achieve here. I'm trying to make sure that as you guys follow along, not only do you guys get a working copy of the project in your laptops or machines, but you also understand exactly what's going on and how everything is working. I'm also trying to make it as simple as possible so that you can take these ideas with you into your own games, and you can it can just help you grow, as opposed to just getting this project done. Because things like camera follow, you're going to be using this in every single game, right? So equipped with the knowledge you have here, you should be able to make a wide variety of camera follows. You don't just need to have a third person follow, right? You might have a platformer from a side-on view, but all the things that we've talked about, you'll need a player target. You'll need an offset. Yes, the orientation of the camera is going to be different, but all the same objects, all the same concepts still will apply there. So that's really what I'm going for. So anyways, I think that's it for this video, and I'll think about what we have to do next, and I'll see you in the next video. All right, thank you.